In 2000, a book came out that had a tremendous influence on me. I highly recommend you get a copy of it. In fact, there is a free copy to celebrate 20 years of this that you can get on Amazon if you're willing to listen to it on Audible. It's called The Pragmatic Programmer. And it has a whole bunch of principles on how to be a more effective software developer. One of those really important principles is the thing that it calls dry. Don't repeat yourself. And the idea behind dry is you have one piece of source code that describes a particular set of stuff, and everything in your application that needs to work with that gets as its source that one source and works forward from that one source. That way, when something changes in it, you change it in one location and you rebuild stuff, or it reuses stuff, or it reinterprets stuff, but you don't have it in multiple locations. And this is a hugely important concept for all sorts of applications. I'm going to give you an example having to do with having a dry source for a table definition. Now, I actually have taken this little table definition that says table user. Most systems have a user table. And I have pulled that out into a separate file. You wouldn't necessarily have to do that. You could go searching through the documentation for the tables if you kept a consistent format. But in this case, I've pulled it out into a separate file. And I've written a little C program that will take this and turn it into the stuff that creates the stuff inside the database to match with this table. Now you go, oh wow, he's going to take a 6-line table definition and he's going to write 300 lines of code or 400 lines of code to build it into a set of SQL that will create the table. This doesn't make any sense. This is way too much work. I'll give you a criteria for when this makes work. If you get 10 times as much output as the amount of input, okay, and I know that sounds like a lot, but if you get 10 times by building a tool, it's worth building the tool and maintaining the tool to do this. Now, I've been some places where this was super valuable, and I've had some cases where it wasn't that valuable. But here's the makefile that goes with this. Now, when we go and build something off of a database table, we may have multiple different things that we're building. I'm only going to show you the example of building one thing. But legitimately, you may have interface routines that go into an application, the definition for the stuff in the database, possibly some sample data that you associate with it. You may have some tracking information that you want to go into documentation for it. You may have a front-end stuff where you want to display this to, say, an administrator for what's their list of users. So all of these things can be built off of just the definition of the table. I'm going to show you one, and we'll take just a few seconds to look at the code. You can go poke through it. It is checked in with today's lecture. But this is a good example of a meta program. Now, you notice one of those things I mentioned there was an interface to the database. Most likely, if you're building in C, then when you build your application in C, then you're going to have this C program write a C program that is the interface. So you can write programs that write programs. And that is a tremendously powerful thing, is not just programming, but metaprogramming, code that writes code. So let's go take a look at this makefile. And there's the makefile, and it says that all I want to build, that's my default target at the top of the makefile, is usertable.sql. And usertable comes from this usertable MD. That's the definition, and this genuser program. The genuser program comes from genuser.o, the object file, which means it's going to have to get linked. And genuser.o comes from this C file and this header file. So we've got a number of steps. Now, I have a custom step in here that says that whenever you get to this SQL, you want to run genuser with this option and pipe the output into this other file. So let's go look at genuser. Genuser is a big, long, ugly C program that basically, if we go down to the bottom of it, it's got some built-in tests, but it reads in a bunch of definitions and then it generates tables, comments, and indexes, whatever those are. But if you're at all familiar with databases, this is the thing called the data definition language, the DDL, to build the database that matches with that table. So lots of these things exist and are used heavily in industry. I just changed this so that we can rebuild it and run it once. And when we look at this in terms of being in some particular piece of industry, okay, if I just do make, it goes out, it's going to compile the source code, it's going to link it together, and then it's going to build the actual SQL. Now, for instance, Google has a communication protocol that they wanted something faster to use internally, and they developed this system called protobuf. Protobuf is a binary communication protocol that allows them to quickly send data between different machines. And other people use protobuf too. They make it open source, and there is a protobuf compiler that takes a protobuf specification and turns it into some kind of code. Last I checked, the compiler can generate code for 14 different languages, like Python, JavaScript, Go, Java, a whole slew of different things. So if you want a fast way to get one program to talk to another program, you can build these protobufs, and they work really well and they're really fast. It's a good, fast communication. But here's a meta program where you write a specification and it generates code. Most people who build compilers don't build the parser for the compiler. We'll come back to this and take a specific look at that in a minute. They use a parser generator. The parser generator takes a specification for the language and turns it into the destination code for that language to actually build the parser. And there are parser generators out there for all sorts of things. So a generator like this that generates code, a program to write programs, is just useful. Now let's look at the input. Okay. I'm going to make that bigger so you can actually read it. But there's our table user, and it has some columns: ID, username, real name, password. And it has the data type of those, and it says whether or not these are indexed. It's kind of a primitive definition, but this would match with an awful lot of small applications. And it has a comment in there. Now, this is a decent way to read it here. You'll notice that up here in our handout, we've got the same information formatted into PDF or HTML, depending on which copy of this you're looking at. That's formatted as a table. So there's a good way to look at it that way. Now let's take a look at what the DDL looks like. And the DDL looks like this. It's got some extra things to do an update and get rid of the table if it already exists, and then it creates the table with some sort of special syntax, and it's followed all of these rules, like whatever this UUID generate not null primary key is. You'll notice the comments now are not on the same line as the names of the columns. They're way down here, and then after this it creates the indexes that matched with our index definition. So lots of times when you start out with an input that you're going to build a meta program for, you want to put it in a convenient format, a domain-specific language for what you're trying to describe. And then you take that domain-specific language and you parse it, you take it apart, you build a data structure, and then you do things to the data structure, and then you output it in the different formats that you want to have. So this is the essence of this entire dry thing, is start out with a good format that keeps it simple and easy to understand, okay, so that human beings can understand it. And then wherever it's going to be used, in whatever form it's going to be used in, you're going to spit it out in those forms. And that's what the program does. Okay? You'll notice that it's got some tests up at the top. It goes and reads this. The read process and the parsing process is actually most of the code in here. And then it's got these 3 generates that it does in order. The generates are the simplest piece. The generates for the comments is some loops over some data structures, and it says comment on, and it prints stuff out. So once you get it read into a data structure, it's a simple thing to build a generator for most of these things and be able to generate code. Now, the really, really common case of generating code is a thing called templates and HTML pages. And most systems out there today are using some kind of a template where they've got some data in the database, they've got a template of how they're supposed to format it, they combine the two together and they build HTML and cascading style sheets and JavaScript that matches with what's in the database to make whatever you see on the front end work. And there are a bunch of different simple systems for this, like Vue.js and Facebook's React and Angular.js that are all complicated, detailed templating systems for building front ends for web pages so that you can mix data with code and end up with a display of what a person is going to see. So this is super common. In fact, there is one complicated templating system that uses a database and a whole slew of rather active templates, and that single system represents 16% of all web pages in the world, and it's called WordPress. And all it really is a fancy templating metaprogramming system that ties a database and a bunch of forms that allow you to update the database with a whole slew of templates that allow you to render for the web this set of stuff to build a blog or a website. So these are super common. Super, super common. And some of them that I use are not just super common, but they are also have makefiles built into them. Now, you go, okay, he took this little specification that was only a few lines of code and he wrote 300 lines of C code to be able to generate 20 lines of output. That doesn't match with the 10-to-1 type of a thing at all. But suppose you have more than one table you want to work with. I've been doing some stuff with an insurance company, and they have 11,241 tables in their data model. With 11,241 tables, it's way easier to write a 300-line program to process this than it is to maintain all those tables. And it's not just tables. The last time I worked with a phone company, we did this for their data model, which was even more complicated than that. And the set of generators, I think there was 8 of them that I wrote, generated 6 million lines of code for 27 different projects at the phone company, and became a very standardized tool that they used for years and years and years. So these things that you allow you to do metaprogramming can allow you to jump forward a long ways. And one of the key concepts in this entire metaprogramming thing is that if you have a generator that generates some set of code, and you send this off to some other group in the business, and they try it, and they say, we found an error here on how it handles dates in this one special case. You can go back to your generator and say, how many people in the entire organization have dates? How many cases do I have? Thousands? How am I going to fix this so that it fixes all of them, so none of them see this error? And your fixes get multiplied by the number of users and the number of applications. So you do one fix that might take you twice as long as if you just fix the code by hand, and suddenly you can fix thousands of problems all over because you fixed the generator, not fixed an individual case. So it allows you to multiply your productivity. And realistically, the process goes through a flow you might not think of. Certainly for the insurance company, I stuck all of those tables into a directory. So I've got a slew of files in the directory, yes. And I use a makefile to do the processing. So the makefile runs ls to get the list of files, and some of those files are not table definitions. So it runs awk to pick out the table definitions. And from this, I generate a makefile as a tool, because make is a really useful programming language for this kind of thing, to compile and build and run all the stuff to build the output for all the pieces. So this is metaprogramming, where I'm using make and command line to data wrangle to produce make files that I then turn around and run at a second level to make it all come together, to build it.